Okay, hello guys. Today I want to cover with you functions, and the first topic that I want to cover with you in functions is parabola graphs, hyperbola, and exponential. But now in this section, I'm going to start with parabola graphs, and then we move on to hyperbola, and then we move on to exponentials. So first of all, before we go deeper into these problems, we need to understand how an equation of a parabola graph looks like. Okay, so first of all, the equation that represents a parabola graphs is given by y is equals to a x squared plus bx plus c, right? And then your c is always your y-intercept, right? So the point where it cuts the y-axis in your graph, that will be represented by c, right? And then the second equation that we use in parabola functions is given by y is equals to a x plus p to the power 2 plus q. Now, this equation is a completed square of that equation. So now, when you are given this equation in this form, then it tells us our coordinates of the turning point, right? So now, when we want our x coordinate of the turning point, then we can take this expression inside this bracket, and we equate that expression to 0, and then we solve and say x is equals to minus p. So now that is our x coordinate of the turning point, and then the y coordinate of the turning point will be given by q. So this tells us that when we are given an equation in this form, that means that our turning point is minus p is to q. So don't get confused when in a problem they give you an equation in this form. This actually is telling you that your turning point will be solved by equating this, your x coordinate will be solved by equating this equation to 0, and then you solve, and then your y coordinate of the turning point will be given by q, right? And then the third equation is given by y is equals to a x minus x1 x minus x2. Now, most of the time, this equation, we use it when we want to calculate the unknown equation, right? So now, your x1 and your x2 represents your intercepts, right? So this means that in your graph, if you are given a graph and then in that graph they give you the intercepts, then you can substitute your intercepts as x1 and x2 and solve to find the unknown equation. Right. Okay. Now let's take a look at the shape of a parabola graph and see how it looks like. So I'm going to make an example by using this one. So let me draw my y-axis, and then let me draw my x-axis. Right. So let me draw the shape of this graph. Let's say maybe we have a graph looking like that one. It turns there, and then it comes back down there, right? So that will be my x-axis, and that will be my y-axis, right? So then remember, a parabola graph has got two x-intercepts, right? And y1 and y-intercept and the turning point. So then my first x-intercept, I'll say that is a, so that will be negative y is to 0, right? And b, that will be positive x is to 0. I hope you understand why I said that is a negative, because it's on the negative side of the graph. So that's why we say that one is a negative x, and this one is on the positive side of the graph. That's why we're saying it's a positive x. And then the y-intercept will, let's say maybe the y-intercept is 0 is to positive y, right? Because this is on the positive side of the y-axis. That is why it's a positive y. And then that will be our turning point, right? So this will be our negative x is to positive y. It's negative x because our x coordinate of the turning point is on the negative side of the Cartesian plane, and it's a positive y because our y is on the positive side of the Cartesian plane. So I'm going to make an example by using this graph, right? So first of all, I know you may want to know how to calculate the x-intercepts. So my x-intercepts is a and b, and my y-intercept is c, and my turning point, there it is. I'm going to say maybe my turning point is d, right? So first of all, what we need to understand in this section of parabola is to know how to calculate your intercepts, right? So first of all, how do we find intercepts in a parabola equation? So let's explain that. Find intercepts. So to find the intercepts on this one, when we want to find the x-intercepts, we always say when y is equals to 0. And to find the y-intercept, we always say when x is equals to 0. So that is how we find the x-intercepts and the y-intercept. But for finding the y-intercept, you don't need to say when x is equals to 0, because if you have the equation, you actually know that the constant value will give you your y-intercept. So you don't need to do this. But for your x-intercepts, you will have to do this, and then you'll solve the equation, right? And the second thing that we need to know is to how to find the turning point. So finding the turning point. So I'm going to say finding TP, right? So there's actually an equations that we can use to find the x coordinate of the turning point, which is given by x is equals to minus b over 2a, right? So this is the equation that we use to find the x coordinate of the turning point. So your b, obviously it will be your coefficient of x, and your a, obviously it will always be your coefficient of x squared, right? And also this equation, we can use it to find it the x's of symmetry. So this equation is effective because we can also find the x of symmetry. So in parabola graphs, when they ask you to find the x's of symmetry, you always use the x coordinate of the turning point, because this is where the x's of symmetry is in parabola graph, right? Because if I cut this graph at this turning point, then this side and this side will be similar to each other. So that's what we mean when we're talking about the axis of symmetry. And then there's actually a second way to calculate the turning point, right? So the second way to calculate the turning point is to find the first derivative of that equation, and we equate that equation to 0. So for instance, maybe I'm going to say, okay, y is equals to a x squared plus bx plus c. And then the first derivative of this equation, we equate that to 0. Then remember, when we differentiate, we always multiply. We take the exponent, we multiply it to the coefficient, and then we subtract with the 1. So that means that it will be 2ax plus b, and then we solve for x. So it doesn't matter which method you use. You can use the equation to calculate the x coordinate of the turning point, or you can use this method of finding the first derivative. Either method, it will give you the same answer, right? Obviously, when you want to find the corresponding value, you always take the original equation and then you substitute that x coordinate to the original equation to get your corresponding coordinate, right? So this is what we do. We take the original equation and we say a, in the place of x we substitute minus b to a to the power 2 plus b minus b to a plus c, and then we find our y coordinate of the turning point, right? So that is actually how we find the turning point in parabola graphs. And the third thing that we need to understand in a parabola graph is to know how to find the range, right? The range is to know how to find the range, right? So first of all, what is the range? So when we talk about range, that means we're talking about the y values of this graph. Where does this graph end and where does it start in the y values? So as you can see, this graph turns somewhere there. Okay, so I'm going to make an example and say the y coordinate maybe of the turning point is positive 6, right? Let me make that example and say our y coordinate of the turning point is positive 6. So then this means that this graph does not go beyond positive 6. So which means it does not go up, it turns at positive 6. So then that means that our range will be equals to y is less than or equals to 6, right? So y is equals to 6 or less than 6. That is our range. That is how we actually look at the range. We always focus on the y values of the graph. Where does it end? Where does it start? And then we write down where it ends. Okay, so what needs to the next thing that we need to understand in this parabola graphs is that, okay, on this side, our graph is increasing, right? So on this side, let me use a different pen. So on this side, our graph is increasing. So this is the increasing side of the graph. So when the graph increases, this is when the values of f in x prime is greater than 0, and up until it gets to the point where it turns. And when it gets to the point where it turns, that is when your f in x prime is equals to 0. Remember, like I explained on finding the turning point, the second way to find the turning point is to first find the derivative of that equation. We equate it to 0, and then we solve for x. So that is what happens as well. So it increases. While it's increasing, the values of f in x prime is greater than 0, and when it gets to the turning point, your f in x prime is equals to 0, and then it decreases again. So then from the turning point, it decreases again. So when it decreases again, then that is when your values of f in x prime is less than 0. So I'm explaining this because I do not want you to have problems when they ask you for the values of f in x prime greater than 0, or your values of f in x prime less than 0. Your values of f in x prime greater than 0 will always be on the increasing side of the graph, and then the values of f in x prime less than 0 will always be on your decreasing side of the graph. So like for instance, let me make an example over here. So let's say for instance maybe this graph, the turning point was facing the other way around, like this one, right? So let's say it was like that. So now this side, if your turning point is facing downwards, then your decreasing side will be this one, and your increasing side will be that one. So this means that for this graph that is facing downwards, your f in x prime less than 0 will be this side now, because this side, it is when your graph is decreasing, and then this is the point where it will turn, and then it will start to increase again. So this side will be your values of x when f in x is greater than 0. So you need to be able to distinguish that. So when the graph is, when your turning point is facing, when the positive side is facing that way, your increasing side is that one, and when it's facing that way, your decreasing side will be this one, and your increasing side will be that one. So you have to be able to distinguish the difference between these two graphs when it's facing that way and when it's facing downwards. Okay, so now so now the third thing that they ask sometimes in these graphs is also you need to know how to look at your domain, right? You need to know how to look at your domain. So what do we mean when we're talking about the domain? Now, the difference between the range and the domain is that when we talk about the domain, that means we're focusing now on the x values of this graph. What is happening? Do we have negative x values, and do we have positive x values? By looking at this graph, we can see that this graph, remember this graph starts increasing from negative infinity, right? It starts increasing because, take a look at this, our graph is on the negative side. So it starts increasing from negative infinity up until it gets to the point where it turns, and then it turns and it decreases up to positive infinity. So this means our domain is both on the negative side of the graph and on the positive side of the graph, our values of x. So this means that now we can say our x values is real numbers, and starts from negative infinity up until positive infinity. So I don't want people to make a mistake and say, oh, my graph now starts there and ends there. No, this graph actually starts increasing from negative infinity. Negative infinity, and it gets to the point where it turns and it starts to decrease up to negative infinity. So you must be able to check out the difference. Okay. Now, the fourth thing that we need to understand is to know how to find the values of f in x prime greater than 0 and the values of f in x prime less than 0. So now let's say, for instance, maybe our x coordinate of the turning point, because this one is going to help us. So let's say maybe it's like -1, right? And then maybe they ask you to find the values of f in x prime greater than 0. So let's say maybe they say find values of f in x prime greater than 0. Find values of f in x prime greater than 0. So now, so remember, this is what we said. We said f in x prime greater than 0 is on the increasing side, right? So which means this is the side that we are looking for. We don't even care about this side, because this side is when this graph starts to decrease. So we're only looking at this side. Then this means that if our x value of turning point is less than -1, then that is all the values when this graph is increasing. So for the answer for this will be when x is less than -1. So this means that we're focusing on all the values that is less than -1, values of x less than -1. That is when this graph of f in x prime greater than 0, it is increasing, and then it stops there. So now then maybe they ask you again to give the values of f in x prime less than 0. Now that is when you look at the decreasing side of the graph, right? Now the decreasing side of the graph starts when the values of x are greater than -1, right? When the values of x are greater than -1, then that's when this graph starts to decrease. And when this graph starts to decrease, that is when the values of f in x prime is less than 0. So then the answer for this one, the values of x for which f in x prime is less than 0, will be when x is greater than -1. So this means in this case, finding the values of f in x prime greater than 0, it is important to know your turning point first of all, because you know that all the values of x less than -1 is the decreasing side, and all the values of x greater than -1 is the decreasing side, and that is the increasing side. So that's how you actually look at this problem. Right, so I'm going to end it there for now, and then let us focus on hyperbola equation, then we can move on to question papers. Right.